We've been talking about 5 number summaries and box plots. We showed an example here using monthly rainfall here in Ephraim, Utah, measured in inches. And we can see a box plot here of that data. Quick note on the box plot, just note that each region represents 1/4 of the data. So for example, between the minimum and the first quartile, 1/4 of my data is in this range. There's also 1/4 of my data between the first quartile and the median. So 1/4 of my data is in this range. 1/4 of my data is between the median and the third quartile. And likewise, the last quarter of my data is between the third quartile and the maximum. Awesome. So we can see the distribution of the data. However, there's something unusual with this one. Sometimes these whiskers can be extremely large due to unreasonably large values. Now, using our example of monthly rainfall, this makes sense. We generally have roughly the same amount of rainfall month to month, but occasionally we have a month or two where the amount of rainfall is just absolutely enormous. We get a lot more than usual. And so how much does that unusual amount of rainfall influence our graph here? Well, that's what we're going to talk about here. We're going to determine what constitutes an outlier. In other words, what constitutes something that really is unreasonably too large. So to find outliers, we need to do 3 things. First, we find the interquartile range. Second, we multiply the interquartile range by 1.5. And third, we find our outlier limits. Okay, our interquartile range is simple enough. We just find the distance or the range of our inner quartiles. That's what we mean by interquartile. We're talking about inner quartiles. So what is this range? Well, we're just looking at the distance from Q1 to Q3. So we just take that difference. Q3 minus Q1, we found in our 5-number summary that Q3 is 0.995, Q1 is 0.31. Take the difference. That's 0.685. Okay, great. That's the first step. The second step, very easy. We just take that number and we multiply it by 1.5. That gives us a value of 1.0275. Now here's where this number comes in. We are going to start at our third quartile and we're going to go up 1.5 interquartile ranges. In other words, in this example, we're going to go up by 1.0275. So we start at 0.995 is actually where the third quartile is. And we add 1.0275 to that. And that will give us 2.0225. We just add the two numbers together. And that will bring me up to this point, just above 2.0225 exactly. But that's one side. That's going to the left side. Now if we go the other way, we start at quartile 1 and we want to go down 1.5 interquartile ranges. So we start at quartile 1, which is 0.31, and we subtract 1.5 times IQR, 1.0275, gives us negative 0.7175, which is down here somewhere in this region. Okay. For the left, notice that this point is beyond the whisker. So the whisker is fairly small. It's still within this range, this distance here. So we're good. We don't have to do anything there. But on the right, our whisker goes beyond this point. So third quartile plus 1.5 IQR gives us 2.0225. The whisker goes beyond that value of 2.0225. Anything that goes beyond that point, that's pretty unreasonable now. So those are what we call outliers. So what do? We bring in our maximum line to match this, and then we indicate those other points with just dots. And those dots are going to indicate our outliers. And this is our modified box plot. This is how we can indicate not just the distribution of our data, but also are there any data points that are just plain unreasonable. And there's your modified box plot.